Well, it looks like you're all getting there in your book, page 74, right? Okay, good news, everybody. You don't have to learn anything new today. All you have to do is take what you already know and put it to use, okay? So we're going to be solving inequalities that are more than one step. We have solved inequalities that are one step using addition and subtraction rules, and we've used solved equalities with one step using the multiplication and division rule. And it was all just like solving equations except for that one thing. What was that one thing? Yeah, if you divide by or multiply by a negative, does it change the direction of your inequality, right? Okay, well, it's the same thing here. We're just going to solve this. It's just two steps now, more than one step. What do you want to do first? All right, we're gonna do the addition property, or subtraction property. Get rid of that. So y over negative 6 is less than 2, and then. Okay, now if I'm going to multiply by a negative, then the direction of my inequality is going to change, isn't it? Okay? So that's it. That's literally the entire lesson. 2v subtract 4 greater than or equal to 8. We're just going to solve inequalities that have more than one step. 2v greater than or equal to 12. Divide both sides by 2. This time I'm dividing by a positive number, so I don't have to change the direction of the inequality. V is greater than or equal to 6. What do you think? Anybody worried about this so far? Okay, good. There will be... Let's talk about the ones that always make you... always weird you out a little bit, I think. Let's look at this one. I think we struggle with these. I'm not sure. I think part of it is you just let yourself go a little brain dead. Wyatt, do you have a hard weekend?
No.
Wake up then. What do you want to do first? Okay, subtract. Now I'm going to show my work a little different here. I'm going to subtract 11 from this side. I'm going to subtract 11 from that side. I showed my work. It's all good, right? Okay. So we have n divided by negative 2 is greater than 1. Now what do I have to do? Multiply by negative 2. See, we want to do the opposite of divide by negative 2. That's all there is to it. So that gives us a 1. Negative 2 divided by negative 2 is 1. So we have 1n. And this is negative 2. And we divide it by a negative, so the direction of our inequality is going to change. Okay, you ready to try one? Too bad. Here you go. I think you're ready. Now this one's more than just a couple steps, but I think it'll be fine. 5 less than 2x plus 11. Do you agree with me?
Yes.
Is that what you got, Thomas? We didn't have to do anything different than we do when we have an equation, do we? Okay? So, same idea. Now, we need to be aware of some weird things. Some things that just don't come out the way we expect them to sometimes. But I think you guys know how to handle this. So first of all, this is a B, not a 6. Can you tell the difference? I know, it's hard. But 8 times B subtract 3 is greater than 8 times B plus 12. So we just use the distributive property. See, I don't want variable on both sides, so I'm going to subtract 8B. But when I'm trying to get rid of this one, this adds up to 0 times B. This adds up to 0 times B. And I end up with this statement right here. Now, you have to think about this. There's either no solution or anything is a solution. And it depends on whether this statement is true or false. Is it false? Okay, it's false. So what does that mean about the solution to this inequality? There is no solution. So here's what the graph of it looks like. Nothing. There's nothing on the number line can go in for B and make this thing true. Just like when you're solving an equation and you get a false statement. These are a little harder to tell if they're false or true sometimes, but you got it. Now, of course, sometimes you end up with something like this. -3 is less than 12. So you don't have any variables left, but you end up with a true solution. What does that mean? Any number on the number line will make it true. In other words, there are infinitely many solutions. So the graph of this one would look like that. Like everything. Now, are either of those two things good? Is that what we want to see when we're solving an equation? Or no? It usually means you've set up the equation wrong from a real problem, okay? You've done something a little weird. So you need to go back and take a look at your setup process. Okay. Turn to page 76. Let's look at the mean score. Do you guys remember the mean? Average? Did your teacher tell you to call it the mean old average? Is that what you heard when you were in elementary? How do we find the mean? Perfect. Add them up. Add up the numbers that there are, and then divide by the number of them. Okay. And that's fine. Okay. But we don't always know. Let me show you an example here. Let's say you work in a manufacturing facility where you manufacture, what do you make? What?
Gold.
We cannot manufacture gold. We could make something out of gold. We could make gold necklaces. Could we do that? Okay, so we make gold necklaces. If we average, or if our mean in this manufacturing facility is, let's say, 800 gold necklaces. Okay, if that's what the mean is at the end of the week on Friday, all of us get a $500 bonus for the week.
That's good with me.
For the week, everybody gets a $500 bonus. Okay, so Monday. You know how Mondays are. I see your eyes right now. Mondays are never good. $700. That's all we get. Tuesday, things go a little better. Wednesday, we hit our groove. We are cruising along, banging them out there. We really did well on Wednesday, but then we run out.
Oh dear.
You know those little claspy things you have to put on the back to make them hook? We run out of those, and we have to wait till Thursday at 10 in the morning to get some more. And so we really can't start working Thursday till late, and we only make 600. So the question is, if we want our $500 bonus, how many do we have to make Friday?
10,000.
I hope it's not 10,000. Figure it out.
800.
Come on, you can do it. Think about it. No, you're not going to. Think about it and figure it out. Does not mean make random guesses until Mr. Caller tells you the answer. It means write it down on a piece of paper and figure it out. Write an equation that will help you solve this. Think about how you would do it if we knew how many we had on Friday. How would we find the mean? We'd add them up and divide by the number of them, right? Well, we don't know all of these, but we do know what we want the average to be. You can do this. Come on.
I don't think I did.
You can know if you've got the right answer because your 5 numbers added together divided by 5 has to equal 800. You know when you get the right answer. You're probably going to need a calculator. Guys, use a calculator.
You can tell me.
Do not throw anything.
Right. Finish the SB2. Okay. Finish SB2.
Come on, what are you coming up with?
I'll know you're right.
That's right.
That's how it is.
That's not going
Exactly. It has to average out. Time divided by 5.
Okay. Looks like a lot of you are coming up with something that makes sense. If we want these 5 numbers to average 800, what do those 5 numbers need to add up to? Why? Why do they need to add up to 4,000?
8 times 5 is 440.
Okay.
And we have
It,
5 numbers.
so the numbers we have, think about it this way too. Plus, what are we going to do Friday? We don't know that. Can I use F for that variable? Okay. When we add these 5 numbers up and divide by what? 5. What do we want the answer to be? We want it to be 800. We want that to equal 800. Now think about this. Remember, parentheses and this fraction line are kind of the same thing. If I want to solve this equation, the first step is I need to get rid of the symbol of inclusion here. I don't want that big fraction line there. Can we get rid of this 5? If we multiply both sides of the equation by 5, what's going to happen to this 5 and this 5? They're going to cancel out. And we get, now we could have added these together, but I'll just leave them separate still. That makes sense? If we think about it that way? See, I just put down everything I knew and put a variable for the one I didn't know and then say, well, I want to divide them by 5 and the answer to equal 800. There's my equation. So now we add all these together and you probably come up with 2,950. 2,950. And then if we subtract that number, now, what if we did more than this? Would your boss be upset?
No.
Do you think there's a chance they could say, well, you get a $500 bonus for if we make this number, and for every one we go over that, you get an extra $5 or an extra $10 or something like that? So most of the time, we don't want the average here to equal 800. We want it to be greater than or equal to 800, don't we? Wouldn't that make more sense? I mean, if the average comes out to be more than 800, is anybody going to be upset? No. So this is real life. Real life, you don't say, oh, I want the average to be exactly 800. Right? Okay? If you're getting a steer ready for the stock show and you want it to weigh, I don't know, 1,000 pounds to take it to the stock show. So do you want that steer, when you walk into the stock show with it, do you want it to weigh exactly 1,000 pounds? No. You want it to be, that would probably be the minimum you'd want it to be, maybe. Okay? Everything's like this. If I need $10 to pay for the movie and $5 for some popcorn and a drink, God, that's not reasonable, but you know. Do I want my parents to give me exactly $15?
$20.
What if they gave you 40? Would you start crying and give half of it back? No, Shannon would scream and run, right? Okay? No, real life is not equal, right? Real life is, I want this much or more, or I want this much time or less. Okay? That's how real life is. Okay? All right, here's your assignment today. Chapter 2.4.
My mom didn't.